Hey, what's going on, guys? Welcome back to the Mizu Study channel. Hope all of you guys are having a great day today. So basically, we're going to run through exactly what we're going to be getting done today. So first of all, I want to start off with one whole HPAT mock. That should take around 2 hours, 50 minutes. No, wait. Wait. 50, 40, 30, 2 hours. Yeah, it should take 2 hours. Then I want to get some maths done, as much maths as I can get done. Then I have a bit of chemistry to get done, a bit of French to get done, and then we're going to end off with some just looking over some English and then just doing some French homework. So let me just write that down somewhere. So we're going to write it down sticky note. So we're going to start off with my HPAT mock. Then we're going to go to do some maths. Yeah. Okay, so we have HPAT mock, then maths, and you finish sequences and series. I'll do proof by induction as well. So I'll get sequences and series done and proof by induction done. I need to do chemical equilibrium. I need to study for subjunctive in French. I need to do my French homework, and I need to just look over a question B for English. So let me just update that, and yeah. So that's my whole schedule. I'll just attach that to my monitor like so. Alright, so we have a lot of work to get done, but we have a lot of hours to get it done. So we have like 10 hours in the day. No, we have 12. It's 11, 1, 11, becomes 12, becomes 12, becomes 10, like 11 hours, bro. So we're chilling. Don't underestimate how much you can get done in a whole 11 hours. Because a lot of the tests, I have biology on Wednesday. I already studied for that. Subjunctive is very easy. And then Friday's chemical equilibrium math. So the two hardest tests are on we have the most time to study for those, so we can study for those during the week as well. So it's not an issue. HPAT mock is the most important thing right now. I think we'll go for a full mock. Okay. We'll do E39 full mock 2. Okay. So HPAT Ireland. So there'll be instructions, navigation. Wish me the best of luck, guys. I got this. So 42 questions. So I have 1 hour. Oh, it's 1 hour, 50, and 40. So it is 2.5 hours. You'll not be able to go back. Okay. Man, you got this, man. You got this. Let's go. Okay. So as a tree grows, it forms growth rings in its wood. Okay, so first of all, we read the question. So when were all three trees alive at the same time? So as a tree grows, it forms growth rings in its wood, and one ring is added each year. Okay, so each year corresponds to one ring. Figure 1 represents a section of wood from a 5-year-old tree, so there's going to be 5 rings, yeah. The rings vary in thickness depending on growing conditions here. When growth is rapid, so rapid growth is going to correspond to thick. In years of poor growth, the rings are thin. So rapid is thick, poor is thin. It is possible to match up the tree ring patterns of different trees of the same type from the same area. So we can see 5 here. So in figure 2, it shows matched tree ring patterns from the 3 trees of the same type. So that grew in the same area. Each section covers the full life of the tree. The sections from the living trees was taken at the end of 2003. So it said when were all trees alive at the same time? So if this is 2003, at the end of 2003, so 2003, 2, 1, 2000, 1999, 98, 97, 96, 95, 94, 93, 92, 91, 90, 89, 88, 87, 86, 85, 84, 83. Only in 1983. Amanda is trying to find out how many droughts occur during a certain time span in the area of her farm. And she has 4 tree ring sections from trees from her farm, as we can see in figure 3. So they've given us another figure. But these have not yet been matched up. So they've not been layered on top of each other. Exactly. So she knows that the sections form an overlapping sequence that covers the time span. Okay, so we can see that all 3 of these have excuse me, all 3 of these have a 3, 9. Okay. She knows that the section, okay, yeah, each section does not necessarily cover the entire life of the tree. Okay, so that's fair. A frost year causes a distinct tree ring 1. A distinct tree ring. A frost year causes a distinct tree ring. There are only 1 frost year during the time span. And aside from frost years, the narrowest rings indicate drought years. So yeah, so thin is poor or drought, and like the really thick, you're gonna see really thick kind of rings. These are our frost years. So it says, what is the total number of years covered by the tree ring sections in figure 3? Total number of years. Okay, so if I overlap this, so okay. So this looks like the biggest, and this looks like it has the most space. Most space before, yeah. So it says, okay. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, 17. It says, what is the total number of years covered by the tree ring sections in figure 1? I guess I'm going to have to overlap these. Okay, so we have, okay, we have a bit of a bigger one there. We have a bit of something like this. We have something like this. I mean, there's something like this, this, like that. Now, this right here, so this right here is same like that. It has this right here, and it has this right here, but then it goes, then it has, so that's 4 years there. Okay, I know. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So that's 19. 19, 19, 19, 19, 19, 20, 21, 22, 23, 23, 24, 25, 26, 27, 28. Should be 28. Okay. So over the time span covered by the 4 tree ring sections, how many such periods were there? So drought periods occur when there is a drought for I had to pause it there, but we're back. Okay. Drought periods occur when there is a drought for 2 or more successive years. And drought, we know, is that when there's a drought, aside from frost years, the narrowest rings indicate drought years. And drought periods occur when there's, okay. So, we have, occur when there's a drought for 2 or more successive. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, I'm not sure if that's correct. Wait. 1, 2, 3, 4, 5, 6. But then 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. I think it's 4. Drought. Okay, over the time span covered by the foraging, how many drought years were there? So there's like 1, 2, 3. There was aside from frost years and Nazarene. Okay, so I mean there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 7, 8, 9, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15, 16, 17. Yeah, 16, 17. Okay, so a biopsy will typically result in a false negative once every. So if a doctor suspects that a patient has a cancer, they may perform a biopsy, which is a diagnostic test in which a small amount of the tissue is removed and examined under a microscope in order to detect cancer cells. So they're detecting cancer cells, a small amount of tissue is removed. The test result is positive if it indicates that the cancer is present, and negative if it indicates that the cancer is not present. Like other diagnostics, biopsies are imperfect. A false positive occurs when the patient does not have cancer with the test results positive, and a false negative is when they actually have cancer. But for a particular type of biopsy, false positives occur in 12% of the tests on patients without cancer, whilst there are 40 negatives per million tests on the patients with cancer. So 40 tests. A biopsy will typically result in a false negative once every Oh, okay. So 40 per million tests. So 40 per million. A million divided by 40 should be like, so a million divided by like 40 is like, okay, that goes in twice, that goes in 5 times, that goes in okay, so it's like 25. Yeah. Of every 10 million tests on patients without cancer, there will typically be how many positive results? So 12% per million. So 12%. So false positive means that 88% 88% for every 10 million tests on a patient without cancer, there will typically be how many positive results? So we have 10 million, right? And it says false positives occur in 12% of tests on patients without cancer. $1.2 million, yeah, positive results typically. And suppose that biopsies are performed on 300,000 patients and that 100,000 of them have a cancer. So suppose that biopsies are performed on 300,000 and 1,000. So we have 100,000 which have a cancer, 300,000 which don't. So how many of the biopsies will typically return positive results? So 300,000 patients and that 100,000 of them have a cancer. But then realize that we're gonna have false positives as well. So out of that 30, what's like, so 30 and then 10%, so 36,000 is also going to be in there. So we're going to get that many positive results. So we're going to get like 103. So we have 300,000 patients, and that, suppose a biopsy upon 300,000 patients, and that 100,000 of them have cancer. How many biopsies will typically return positive results? So first of all, we have to account for 12%, which was going to be 36,000. And then I said, okay, there's going to be 40 false negatives. And then we get 40 false negative cases, but that's per a million. So if we divide that by 10 and we multiply that by 3, so divide by 10 is 4, 3, so we get 12. So we get 12 false negatives, so minus 12 of that. So if we get then 136,988. I don't know why I'm getting 136. If 12%, because 10% is 30. And false positives are going to occur. At the same time, false negatives are also going to occur. It's not this and it's not this. Without cancer. 200,000. And then 200,000 and then 12% of that is 20. It's 24. So 120. So that's like 124,000. Whilst there is 40 false negatives on the patients with cancer. 4. I got it. Okay, which of the following is a valid conclusion that could be drawn from these results? Each blood is made up of various components, 3 of which are red cells, white cell platelets. Samples of blood were removed from 2 people. Each sample was analyzed to determine the composition of the blood. Person X is known to be a sufferer of a rare disease, and so X is disease and Y is no disease. Yeah? Which of the following is a valid conclusion that can be drawn from these results? Okay, so it says the rare disease is caused by having too many red blood cells. No, because their red blood cell numbers per milliliter are really similar. Person X has more red cells and fewer platelets than is normal. More red cells and fewer platelets. Okay, there are variation. The rare disease causes a drop in the average number of platelets per milliliter of blood. There are variations between people in the number of each type of blood cell. I think that's the best one because We don't know if person Y is normal. They may have another disease. They may not have that disease when they have another. Based on the above information, which of the following is true? So glucose is one of our cell's main energy sources. The process follows the steps of converting one molecule to another to finally create a molecule that can be used by our bodies. This process is called glycolysis. Yeah, depicted in the diagram below. Each arrow indicates the direction of the conversion. On the upper left is the chemical structure of glucose. Okay, the lines showing these symbols. Okay, they are called bonds. Okay, double bond. Two stripes indicate two bonds. It takes energy to convert glucose to the next molecule in the cycle, is represented by the ATP. ATP carries energy, which gives a way to facilitate the conversion of glucose, molecule A. After ATP loses energy, it's called ADP. So one arrow between ATP and ADP essentially indicates that ATP was used and 1 unit of energy was lost. Sometimes energy is actually gained through the conversion process of one molecule to another. An arrow pointing from ADP to ATP indicates that ATP was produced, and so if ATP is going to ADP, 1 unit of energy was lost. ADP to ATP, 1 energy is gained. So molecule D can then be converted to molecule E. That's why are called phosphate groups. Based on information, which of the following? Glycolysis produces the same number of ATP as it uses. Not necessarily. I don't think so. When a phosphate group is removed from one of the molecules in its pathway, A, B, H, and when a phosphate group is removed from 1 unit of energy is lost. No. Yeah, because when it no. Overall, glycolysis is an energy gaining process. No, that's a trick question. The atoms that become part of molecule D exit the glycolysis process. Yeah, I think that's the pyruvate. The molecule that comes out of glycolysis process is converted to acetyl-CoA. Through this process, 1 unit of energy is gained. Acetyl-CoA then enters a process called citric acid cycle. Through the process, in the next step, molecule A loses 1 oxygen and 2 hydrogen atoms, just taken out of the system as H2O. It is now called the molecule B. Adding 2 hydrogen atoms, 1 oxygen atom, this time in a difference. So 1 unit energy is gained. The GDP to GTP conversion is a process that is similar to ADP to ATP conversion. It gains 1 unit of energy. The same goes for Q and QH2, NAD plus to NADH when the cycle goes all the way back to molecule 2. Considering the additional information, which of the following statements can be concluded? The citric acid cycle refers purely to the molecules in the cycle, not the conversion of pyruvate to acetyl-CoA. CoA refers to coenzyme A, which is essential in the conversion. The overall says the overall energy pyruvate contributes 3 carbons, 3 oxygens, and 4 hydrogen atoms to the citric acid cycle. So pyruvate is coming in. Okay, no. The coenzyme A were to malfunction, the citric acid will stop working at the conversion of molecule D to molecule E. Molecule D to molecule E. For each initial glucose molecule, 2 GTP, 6 NADH, and 2 QH2 will be formed in the citric acid cycle. For every initial 2 GTPs, and overall the energy gain for each molecule that passes through the citric acid is 6 energy units. No, I don't think so. Pyruvate 3 carbons. No, it doesn't. Which of the following can be concluded from the information above? So this pie chart shows the pattern of changes in the asthma severity of patients at 1 year follow-up. Okay, so patients in the improved group, in the improved group had milder asthma severity than the people in the no change group. No. At least 48.1% of people experienced a worsening of asthma severity at the year 1. At least 7.8 participants were offered initial treatment at initial diagnosis. No. 44.2% of participants experienced neither improvement nor worsening. Neither improvement, so no change, nor worsening. No, because that's incomplete data, so we can't assume that. Of the people who had a definite change in their asthma severity at 1 year follow-up, what percentage did not have an improvement? Definite change. Of the people who had a definite change in their asthma severity, so definite improvement, definite change in their asthma severity, which is this and this, which is definite. We don't know about incomplete data, so that's 55.9. 55.9% of the people who had a definite change in asthma severity at 1 year follow-up. What percentage did not have an improvement? So 48.1% is looking like, if I divide 5 into this, 50, and I get 10 over 11, which is equal to like, it sounds what's 10 divided by 11? I mean, 10 over 12 is the same as 5 over 6, which would be like 32, 32, 32, which would be like 16, 16, 16, 16, 16. So 5 by 6 would be like 80%. 80 something. Man, I don't know. I mean, 80% would be like 44. So then it's probably 86. This study found that there were 312 people whose asthma severity improved at 1 year follow-up. Which of the following can be concluded? So, but that's incomplete data. Excuse me. So, around 312 divided by 7 is like, it goes in like, it goes in 4 times 3, it goes in 4 times the remainder 4. So it's around 444. Okay. So which of the following? There were at least 1960 people who were worse at the. I mean, if 312 divided by a 7 is giving me 4, it's giving me 3, and it's going in like 44. Alright, let's say 44, right? 44 multiplied by 50 is going to give me 414 multiplied by 5 is going to be 2220. Yeah. Which one can be? The maximum number of people who could have improved, no, because there were 4,000 people from whom complete data was obtained. I mean, 444 multiplied by 95. No, sorry, 9.5. There were at least 1560 people, because 4 no change. So 39. So I have like 44 point something, right? And 48.1. So if I multiply this by 5, I get like 2220 approximately. 2220. There were at least 90. There were at least 15, 6 people who did not. So it's either 1 or 4. Okay, this is difficult because there were at least 15, 60 people who did not notice a change at all. If I multiply that by 4, it's above 1560. And if I do this one, it's also above 1960. What happens if I divide 312 and I divide it by 12 instead? And I go, okay, that goes in 2. Okay, I have 7 remainder. That goes in 5, 6. That goes in 26. Okay, let's say I have 26. Okay, then I'm like 1% of it is multiplied by 50. So I get 265, 20, 1000, and 1020. I get 1020. It can't be that. And then 40, I say 10, 10. So that's like 520, 520. And let's say if I say even 10, let's say if I even go 312, let's say I say 31.2 represents. Yeah? I multiply this by 50, I get 312 by 5, which gives me 1500, which gives me 1572. And then 40. Alright, let's go with this. I can't waste too much time. Hypothetically, what is the minimum number of patients who could have to who would have to transfer from the worst group to the no change group for the no change group to be the largest? For the no change group, how many people? Worst group to the no change group. From the worst group to the no change group. I mean, you need approximately 9%. It's about okay. 9 by 40, 44 by 9 is going to be like 300 and like something. Okay, I don't know, kind of winged it there. At the end of a round, one player's collection contains the following cards: DK, CA, H9C. Okay, all this. How many penalty points did this player get for this round? So Rickety Kate is a traditional card game with the following playing conditions. The game is played by ordinary fact. So we have 52. So we have clubs, diamonds, hearts, spades. There are 13 cards in each suit. So 13, yeah. The game is usually played by 4 people. The pack is shuffled and each player receives 13 cards initially. The players then play a round. During the round, players collect or lose cards so that at the end of the round, any one player will have from 0 to 52 cards. The players then sort through the cards they have collected and separate out those which attract penalty points. Each of the 13 hearts attracts 1 penalty point. So all of my hearts is 1 penalty. Three of the spades. For example, the spade ace attracts 7. So the spades, the ace attracts 7. The king attracts 10. And the queen attacks 13. A player whose collection contains H4, spades ace is 7, and a heart. Heart is 1. Yeah. At the end of a round, so one of them is a, at the end of a round, a player's collection contains the following. So D, so we only concerned with H and S. H and S. So they have one, S king is 10, SK 1, and SJ is nothing. So that's like 14. Because we have one A. No, we have 1 hearts, 2 hearts, 3 hearts, 4 hearts, 5 hearts. So we have 1, 2, 3, 4, 5 hearts. No, it's 15 then. Which one of the following isn't a possible distribution of penalty points among the 4 players for a round of Rickety Kate? Okay. So only 3, which is not possible. So only 3 of them. So 7 excuse me. So 7, 10 and 13. So 3, 3, 3, 3, 7, which means we used one of them. We used 6 of our hearts. And then we have 7 hearts remaining. And we have 23 and we have 7. So that's no 23 and okay, wait. So we said how much we have in total? We have 23, we have 30, we have 43 in total. We have 43 available. We have 6, so we have 7 hearts remaining. So 7 hearts, 10 to no, that's possible. 24, 8, 6, 5. So 5. Okay, I took 5 from that, and I took 6 from that. So that means I have 2 hearts left. This guy probably took that, so I have that's gone, and 1. So I have 1 heart left, and it's 26. It's not possible. How many rounds can a game last before an overall winner is decided? The players play 1 round after another, keeping their community cards penalty cards until one of them has accumulated more than 50 penalty points. To be fair, it could be 2 or 3. It could be 2. It could be 3. Because even if all of them added together is 30 plus 43, so there's 43 to go around each round, right? So 43, if I distribute like 10 to each person each time, I don't think you could get to a 5th round. So I'm gonna say 2, 3, or 4. For a round in which there's a sole winner, what is the highest possible number of penalty points that the winner can get? For a round in which there's a sole, what is the highest possible number of penalty points? I mean, if we go in and we need 50, we could have 39. So yeah, we could have, that's a possible number. 39 and then we need to get 11. So I think, yeah. There are 3 essentially different ways for players to score 11 penalty points. And how many essentially different ways can a player score 20 penalty points? I mean, okay, you can score 1 by 10. You can score, you can score, you can score 1 by 13 plus 7. You can score maybe a plus 7. You can score a 13 plus a 7. you can score a 10 plus a 10. You can score a, so I did 7 plus a 13. I did 10 plus 10. Did I do 13 plus 7? Did I do did I do did I do 10 plus 7 plus 3? I think there's like 4 different ways. So the figure 16%, the figure so the figure 16% near the center of the diagram represents. So this unit is based on material from a survey on the subject of relationships between occupation, social class, support for either an Australian Labor Party or Liberal Party. In the survey conducted in the 3 suburbs of the capital during 1962, each member of a sample group of manual workers and a sample group of non-manual workers were asked 2 questions. To what social class do you belong, and which party did you vote for in the last federal election? So we have 2. We have Labor and we have Liberal. And then we have 2 classes of workers. We have non-manual and we have manual. Only those who said they voted for the Australian Labor Party or the Liberal Party in answer to question 2 were included in the results. Only those who said they voted Australian Labor Party. The answer was either middle working. The results are shown. So 16% shows that most of the non-manual workers voted ALP. No. All of the manual workers who voted ALP and all of the manual workers voted ALP and also identify themselves as working class. Yeah. Most but not all of the manual workers with ALP and also identified. Most but no. And all of the non-manual workers identified themselves as working class. All of the non-manual workers who identified themselves as working class and also voted ALP, and all of the manual workers all of the non-manual, they try to catch me out. What proportion of the non-manual group identified themselves as working as class voting ALP? So we have 46 and we have 54. So this is ALP. So I'd say 46 out of 100. 46 out of 100 is the same as 23 out of 50. What proportion of the non-manual group who identified themselves as working class? It's tricky, guys, man. So that's 20. That's 4 and 5. Which one of the following most accurately states what is represented by 18% on the diagram? So 18% conformed to dominant pattern of their sample group, i.e. manual workers, with respect to voting, but not to class identification. Deviated from their sample group, i.e. by identifying with the middle class. So with respect to voting, but not deviated from their sample group, i.e. manual workers, by identifying with the middle class and voting liberal. No. No, that one looks the most accurate. The information suggests which of the following. Okay. Plant growth is influenced by many factors in the environment. The direction of growth response made by a plant to an environmental stimulus is called a tropism. Geotropism refers to gravity. Negative geotropism, plant go opposite direction of gravity, such as shoot growth. Positive geotropism refers to a plant growth in direction of gravity, such as root growth. Below is a diagram showing the results of plant growth in two different situations. The clinostat is a device which slowly rotates when power is supplied. This rotation exposes all sides of the plant to both positive and negative geotropism throughout the cycle. The plant on the left is of a plant which has always been attached to a clinostat, and note its horizontal orientation. The plant on the right shows the plant under normal growing conditions. So clearly, no. The clinostat rotation may allow to abnormal. It's not ignoring the effects of gravity. The clinostat rotation may allow the plant to experience abnormal plant growth. No, because it does. Because that's normal geotropism. The clinostat causes plants to ignore the effects of gravity. Not necessarily. It's so yeah, that makes the most sense. Which of the following can be inferred from the information? So, rotation of the plant results in abnormal plant growth. Exposing all sides of a plant to a positive and negative geotropism results in horizontal plant growth. No, because we have a clinostat. The clinostat in any position always causes no. A clinostat operating in a vertical direction will cause to go horizontally. Which of the following can be concluded? So what was this? Can be concluded from the information. In normal plant growth, roots experience negative geotropism. I mean, yeah, they're growing. A clinostat causes positive geos on the roots. No. The exposure of all sides of a plant to the same gravity will make counter. Then exposure of all sides of a plant to the same following this information, it is most likely that so plants can either go towards or away from the stimulus. When a plant grows towards the stimulus, refer to positive tropism. When the plant grows away from the stimulus, refer to negative tropism. It's most likely that normal root growth is a positive. No, that normal shoot growth is a negative phototropism. No, normal shoot growth is a positive higmotropism. No, normal root growth is a positive geotropism. Yeah. In regards to blood transfusion, which of the following can be deduced from the above information? In transfusing blood from one person to another, the bloods of donors and recipients are normally classified into four major OAB blood types as shown in figure 3:1, depending on the presence or absence of two antigens. The A and B antigens are specific markers on the surfaces of the red blood cells. Because of the way these antigens are inherited, people may have neither of them on their cells. They may have one or they may have both simultaneously. So there's both antigens, there's A and B, and they're anti-Gs. when a type A antigen is not present on a person's red blood cells, substance known as anti-A antibodies we have in the blood. No A, we get anti-A bodies. And also when a type B is not present, no B, we get anti-B bodies. These antibodies cause the destruction of any red blood cells. Carrier A, B is red because this is the blood transfusion only occurring situation when the donor's antigens and receivers antibodies do not clash. Regards to blood transfusion, which of the following can be deduced from the information above? So, Okay. A person with blood type B cannot receive type A blood. A person with a blood type AB um, a person with blood type B cannot receive. A person with blood type AB can only receive type AB blood, of course, or type O. No. A person with blood type B can receive only type A and type B blood. No, because if they receive anti-B, no, that wouldn't work. A person with blood type B cannot receive. I think that's the most logical one. The above information suggests which of the following. Irish is determined by two genes. One of each is paired chromosome. Genes are special codes to give body instruction on how to construct things. These genes are located within the structure chromosome. Chromosomes are present in pairs. RH indicators are called RH factors. These are C, D, E, C, D, E. A person who has a capital C antigen does not have a C antigen, but the person who has a missing C antigen always has a C antigen. This applies to D, E. Every person who has one of these two pairs, capital letters denote the antigen, non-capital letters denote. So C antigen, C no antigen. The RH blood type is determined by two genes, one on each of the two paired chromosomes. Okay. So if you have capital D, you're positive. No capital, no D plus is negative. So a person with R2 blood, so R2 they have CDE. Their rhesus positive. A person with RR blood, so RR blood can be their rhesus negative. A person with R1R, so R1R, which is CDE, a person can be regarded as rhesus negative. No. Which of the following can be inferred from above information, assuming that the person has never had a blood transfusion? An RHD plus person given RHD minus anyone who has this type of antigen is positive, whereas a person without is negative. People have no spontaneous anti-rhesus antibodies. Okay, so yeah. So the blood antibodies responsible for causing transfusion reaction develop spontaneously. Spontaneous antibodies almost never occur. Instead, the person must be firstly massively exposed to the RH antigen. So if you give a negative person positive, yeah. Following this information and assuming that the person has never had a blood transfusion, it can be infused that a person with B Person with B, RHD minus. Person with AB, so AB, and they have rhesus D negative, can only be given rhesus D negative. No. Okay. How to use a relationship chart to find the relationship between two individuals with a common ancestor. Follow these instructions. Assuming individual A is the 3x great grandchild of the common ancestor. So 3x great grandchild column along the top of the chart to make things simple. Assuming that individual B is also a 3x great grandchild, place them in 3x GR. Yeah. A grandchild row along the left hand side of the chart. Follow both lines intersection and you find that I have three first cousins. I have three first cousins. The second oldest cousin, Narlia. Right. So I have the second oldest cousin. Narlia gave birth to her first child. So you have so you have one grandchild. What is my relationship to I have three first cousins. I have three first cousins on my mother's side. Cousin's your uncle or auntie, daughter. I have three first cousins on my mother's side. Okay. Niece or nephew. What is my relation? The second oldest cousin. Assuming an individual A is the 3x great grandchild of common ancestor, place them in the 3x. Okay, so 3 great grandchild. Yeah, second cousin 2 removed. My wife is pregnant and we are expecting our first child in July. What will my relationship be with Tessa? Because if that's second cousin removed and we're expecting our first child, what will be my child's? What will be my child's relationship to Tessa? First cousin. First cousin once removed. What will be the only possible relationship my grandchild could have with another individual if they are in the same generation, both related to my grandfather? How with another individual if they are in the same generation? They're in the same generation and both related to my grandfather. Which of the following mistakes do we know the second scholar made? An analyst of a now dead Australian Aboriginal language makes the following meaning based translations after years of studying the language. Assume that the same word has the same meaning no matter what phrase it's used. Wait.